Today, we're going to talk about a way of teaching math that's so different, so hands-on, it can feel a little bit like magic. It's about taking numbers off the page and putting them right into a child's hands.
So, let me ask you a question, and be honest. Who here genuinely, truly loved math when they were little? Yeah, for a lot of us, that's a tough one. Math class often brings back some not-so-fun memories. This quote just hits the nail on the head, doesn't it? That feeling of just being told a fact and having to memorize it. Endless worksheets, flashcards. You never really got to ask why. You just had to spit back the right answer. And that's where so much of that early math anxiety comes from.
But what if you could flip that whole experience on its head? What if, especially for our youngest learners, we could build a foundation for math that wasn't about memorization at all, but about a deep, genuine understanding? Well, that's exactly the idea we're going to unpack.
You can really see the two worlds collide here. You know, the traditional way often throws these abstract symbols at a kid and says, memorize this. The goal is just get the answer right. But the Montessori approach? It's completely different. It starts with real, physical objects that you can actually hold and feel. The focus isn't on the answer, it's on understanding the process.
And this isn't some trendy new thing. This comes directly from Maria Montessori herself. She believed that to learn something like arithmetic, you had to start with your senses. You have to see it, touch it, and experience it before it can ever make sense as a symbol on a piece of paper.
So what does this actually look like in a classroom? Well, it all starts with the absolute basics, building a super solid understanding of the numbers 1 through 10. I mean, before you can even think about doing big equations, you have to truly, deeply understand what 4 is.
And these are some of the incredible tools they use. With the number rods, a child can physically feel that the 10 rod is way longer and heavier than the 1 rod. They're not just told it's bigger, they experience it. Then, they trace these rough sandpaper numbers to connect that physical quantity to its written shape. And get this, with the spindle boxes, they put the exact number of spindles into each slot, and they see with their own eyes that the box for 0 gets nothing. The concept of 0 becomes real. Okay, so once a child really truly gets 1 through 10, things get, well, honestly, kind of jaw-dropping. This is where we get to the famous golden beads, and where the entire decimal system becomes a hands-on building project for a 4-year-old.
And this is the whole point. It's one thing to tell a kid that 1,000 is a big number. It's a completely different thing for them to hold one tiny little bead in one hand and a heavy, dense cube made of 1,000 of those beads in the other. That physical sensation, that contrast in weight and size, that's a lesson that sticks with you forever.
And the logic is just beautiful. It's so clear. You start with one little bead, a unit. Then you see a bar that's made of 10 of those beads. Then you see a flat square that's made of 10 of those bars. And finally, you see a big cube that's built from 10 of those squares. The kids are literally constructing our base 10 system, and the relationships, unit, 10, 100,000, become completely intuitive.
So how do we put all this knowledge into action? Well, that brings us to one of the coolest parts of Montessori math, the bank game. This is where kids use the beads to do some seriously impressive addition.
Now, they start with something called static addition. It's a really smart first step. All it means is that when you add everything up, the total in each category, the units, the tens, and so on, won't be more than 9. So you don't have to worry about carrying over just yet. It lets them focus on the simple, pure act of combining groups.
The game itself is awesome because it's so active. A few kids will get a number like, say, 1,324. They take a tray, go to the bank, and actually collect the materials. 1,000 cube, 300 squares, 2 10 bars, and 4 little unit beads. Once everyone has their beads, they all slide them into one big pile on a mat. And then, together, they just count up what they have.
And what you see is just incredible. We're talking about 4- and 5-year-olds adding up multiple 4-digit numbers and getting a sum like this. They're not scribbling on a worksheet. They're physically combining objects and counting the result. It's addition made real.
And of course, the system grows with them. The next step is dynamic addition. This is where they finally learn to carry the 1. But it's not some abstract rule they have to memorize. If they count, say, 12 unit beads, they physically take 10 of them back to the bank and trade them in for 1 10 bar. It's a fair exchange. It just makes sense.
So you might be thinking, why all the elaborate materials? Why the beads and the games? It's because the real goal here isn't just about getting the right answer. It's about something much, much bigger.
What this method really teaches, at its core, is that an operation like addition isn't some scary, complicated thing. It's just putting groups of stuff together. That's it. Subtraction is just taking stuff away. The whole thing is completely demystified.
And this quote just says it all, right? The point isn't to turn a 5-year-old into a human calculator. The point is to give them a real feel for what's happening, an impression of the nature of adding or subtracting. It's about the why deep down, not just the how.
By starting with this physical, playful, concrete work, a child builds a relationship with math that's founded on discovery and curiosity, not on anxiety and fear. They're literally building their own understanding from the ground up, and that's something that can stay with them for life.
So that kind of leaves us with one final thought to chew on. What if math, for all of us, had been less about a race to find an answer and more of a hands-on journey to discover the beautiful, logical process behind it all?